Today's debate is against Stefan Martin Almstadt. Stefan is a Globe Earther admin from the Flat Earth Debate Forum on Facebook, who likes to talk smack against the Flat Earth. We'll also be debating a longtime debate board member, Theodore Akoka, who claims to be a high school science teacher somewhere in the United States. Now let's see if we can change some minds today concerning Newton's third law. Here's some context to get us going.
Kyle Adams doubts the reality of Newton's third law of motion, action, reaction. Pull your hands away quickly and try to right yourself. Can't be done. However, if you push against the wall even gently, you right up like that. It's because I push against the wall and the wall pushes back against me. That, my friend, is Newton's third law of motion.
Okay, Stefan, do you agree that a sheet of toilet paper for a wall could not provide an equal and opposite reaction to be able to support Danny's body weight?
The toilet paper wall will apply an equal and opposite force.
Okay, there's our initial disagreement. Now what do you think, Theodore?
I agree, one sheet cannot hold Danny's body weight. However, there is an equal but opposite force on the contact point between the toilet paper and Danny. The force experienced by the toilet paper from Danny will equal the force experienced by Danny from the toilet paper. When the toilet paper breaks, there will be no more interaction, however Danny's will be slowed by a minuscule amount from the interaction. It provides an equal and opposite force to retard Danny's body weight by a very small amount. If we continued to add sheets of toilet paper, Danny will be affected more and more until a point where we reach a point where Danny will be stopped by the many sheets of toilet paper. Your misunderstanding of the third law is legendary, Kyle.
You just don't understand. Sorry, you'll have to do better than that.
What happened to the third law of motion? Where is the equal and opposite reaction?
If the reaction force was equal and opposite, the toilet paper wouldn't move. Do you agree that the toilet paper moved due to an imbalance of forces?
Yes.
Yes, some part of it moves.
But the force felt on each surface, the contact point on Danny's body and the contact point on the TP, this is equal and opposite. The reason Danny keeps moving is that once the force of Danny's body exceeds the tolerance of the TP gives way and there is no longer an interaction between Danny and the TP.
Okay, Theodore. You agreed that the toilet paper moved because of an imbalance of forces. Yet you also claim that the forces are equal and opposite. That sounds like a self-contradiction to me. Do you agree that equal and opposite forces are balanced forces?
No, not in every case.
Stefan, do you agree that objects that experience a balance of forces don't move?
If the net force acting on the object is zero, then yes, it won't move more than it already was moving if it was already moving.
Do you agree that the toilet paper moved because it did not have a net force of zero?
Yes, I agree.
Since we agreed that the toilet paper did not have a net force of zero and moved because of an imbalance of forces, do you now retract your statement that the toilet paper wall will apply an equal and opposite force?
No.
You appear to be contradicting yourself then.
You are conflating which object is experiencing the forces. The toilet paper exerts an equal and opposite force to your hand, not to itself.
Okay, do you both agree that this force diagram depicts balanced forces?
Guessing by the vector magnitudes and direction and assuming there are no other supports or forces acting on it, then I agree.
Yes.
Okay, Theodore, do you agree that this diagram depicts an imbalance of forces?
Yes, but without numbers, can't know for certain. Yeah, arrows can depict proportion, but again without numbers it is ambiguous.
Do you agree that the blue arrow is proportionally bigger than the red arrow?
Yes, but without numbers, can't know for certain. Yeah, arrows can depict proportion, but again without numbers it is ambiguous. Honestly, is there a point to this? Sure, we can approximate all we want, but the point is to calculate results, is it not?
Theodore, do you agree that the toilet paper moved due to an obvious imbalance of forces, even though you have no numbers available to know the exact numbers behind those forces?
Yes. But you felt the same force that the toilet paper felt. The toilet paper was just weaker. You are going around in circles. I explained this very well in my text I sent. This is simply backtracking to obfuscate the issue at hand. Doesn't matter what the different force are, it is what force each object experiences. How can the paper have more force on it than it please to you?
Theodore, do you agree that an object that experiences a balance of forces should remain stationary?
You are conflating second and third law. I'm done for today. If you cannot sit and think hard on this concept and reread what others have said, this is a waste of my time. You cannot claim that the third law is broken because the second law works. It is just a gross misunderstanding of the concepts.
Whew. And with that, Theodore has chosen not to answer whether he agrees or not, and withdraws from this debate. Okay, back to you, Stefan. Do you agree that this vector diagram depicts balanced forces?
Guessing by the vector magnitudes and direction and assuming there are no other supports or forces acting on it, then I agree.
When the force of my hand exceeds the normal force from the toilet paper, do you agree that this depicts an imbalance of forces?
If the applied force on the toilet paper exceeds the structural limit, then an imbalance occurs.
Okay, that doesn't tell me if you agree or not.
I agree there would be an imbalance of forces if the force from the hand exceeds the force that the toilet paper can withstand, its structural limit, or the normal force exerted by whatever is supporting the toilet paper. This imbalance would lead to the toilet paper tearing or moving.
And with that, we have a resolution. Not every action has an equal and opposite reaction. Therefore, Newton's third law of motion is wrong. Thank you all for watching.